Hello all, I'm going to be gone today, so this is for those that are here when I'm gone, or for those that are absent when I am here. You can get a little bit of explanation on some of this stuff. So last week we talked about the ideal gas law, and so we're going to put that into practice today. Just a little reminder that the ideal gas law is pressure times volume equals N, which is the amount of a substance in moles, R, which is our constant, and T, which is temperature. R will always be given. 0.0821 is the number value for R, and the temperature part of it needs to be in Kelvin. So if you do get Celsius given in the problem, you will add 273. Pressure needs to be in atmospheres, volume in liters, and temperature, like I said, in Kelvin. And then the N will be in moles. I guess I should have put it on this paper to remind you that, but you should always convert into moles if you're giving something else. So for each of these problems, they're going to use this equation. And things I want to see are your identifications, so what P, V, T, and N equal. If you want to write the R on there, that works too, but you don't have to because it's always the same. Then you will solve the law for whatever your variable is requesting, and then write down that new equation. So that's kind of what I want to see. I'm going to show you one example. Number 6 is the one I'm going to do. Because it has the most steps in it. Sorry about the vibrating there. So number 6 on the back is the one I'm doing. Show you how I do it and how I want it done. And then if you have any questions, you can just let me know. So starting off, calculate the pressure. So P is what we're looking for. It gives us 212 liters. That will be our volume. 23.3 kilograms. This is actually our N, and we're going to have to convert that to moles. I'm going to show you how to do that in just a second. And then it does tell us argon is the element. We're going to need that for our N part. And then 25 degrees Celsius, that will be our temperature. And we are going to have to convert that as well into Kelvin. So we'll start with the N, just because that comes first. This kilograms, 1 kilogram, the prefix kilo means 1,000. So 1,000 grams is 1 kilogram. So because we have 23.3 kilograms here, that ends up being 23,300 grams of argon. And we're given, where we now have grams, we can convert that to moles with our stoichiometry that we've done for the past few weeks, so nothing really new here. We do need to find argon's molar mass. So here's my periodic table. Argon is over here on the right. Sorry, I got something on it. But argon is 39.948. We're going to round that to the nearest whole number, so argon will need to be 40 grams. And because we have grams on top here, our 40 grams will go on bottom, and 1 mole of argon on top. Grams of argon cancels, so we're going to do 23,300 divided by 40. And that will get us our moles. It ends up being 58.3 after I round for significant digits, and that is moles of argon. We do need to put our temperature into Kelvin. Celsius doesn't work for most formulas, so we always need to put it in Kelvin, and you do that by adding 273. So 25 plus 273 ends up being 298 Kelvin. That's what we need to have it in if we're going to use the R that we'll always use. So now that we have our conversions done, we need to reformulate our formula, PV in RT. and we're trying to find pressure. So to get pressure by itself, I'm going to have to divide both sides by V to get it away from the P. So I end up having P equals nRT over V. So this is the formula they're going to use. This is what I want to see. Now we plug in numbers, and I'm going to do it a little bit differently than I have in the past, just for this one time to show you something. The N, we calculated out, that's 58.3 moles. You don't have to show me the units here. I'm going to put it on this one. Normally I won't do it either, but what I want to do is show you how the R value with those units translates everything and cancels stuff out, and you're left with what you need and so on. So like I said, you don't have to show me the units on all of them, but you do need to at least show me the number you're multiplying here. Next is our R. R is 0.0821. That was given on the first page, and that is in liter atmospheres over mole Kelvin. And then finally our temperature we calculated to be 298 Kelvin. And on bottom, our volume was given at 212 liters. So to deal with the units, it's just like we did with stoichiometry. If you've got one on top and the same one on bottom, they cancel. So you've got some on top and then even a top bottom here, and then liters are on bottom there. So because we have moles, and then moles on bottom of that divisor, those would cancel. Here, our Kelvin and our Kelvin here that's on bottom cancel. And then liters is on top and on bottom there. So we're left with atmospheres. That's going to be our final unit. And that's what pressure is measured in, so that's where we get that from. You don't have to show me the unit stuff every time, but I just wanted to show it to you to show it to you. Calculate that out. I get 6.7280, and there's some other numbers. I just cut it off there. So we need to look at our givens in the problem to figure out our significant digits. And you always look at what's given in the problem, not these that you calculated out. Because here, 25 has 2 significant digits, but 298 has 3. And so you can't just change it. You have to go with what's given. So we were given 212, that has 3. 23.3 has 3, and then 25 has 2. So 2, it will be how many we will use. So there's my first 2. I look at the next one for rounding purposes. 2 doesn't tell me to round up. So this ends up being 6.7, and then our unit that was left over for pressure is atmospheres. So this is what I want to see. Things I'm looking for grading wise. I want to see you identify the variables, and you can just underline like I did and say like this is V and this is P, this is N, and this is T. That would be acceptable, or you can write them out over here. Either way, as long as you identify the variables. I also want to see the equation you end up using after you rearrange it. I want to see your numbers plugged into the equation, at least the numbers. You don't have to show me the units, but the numbers at least. And then I want to see your final answer with correct sig digs and the unit. So 4 things I'm looking for. If you have this other stuff like I do, that's perfectly fine, but I don't necessarily need to see it. It does help me if you do something wrong. It helps me figure out what you did wrong so I can help you out. But I at least want to see those 4 things on every problem. Just kind of a heads up on number 5. This gives your N in grams. So you do have to convert to moles, and it is O2. So O is is 16, so this makes O2 32 grams per mole. And then you got to convert Celsius in most of these, so that'll be the same, but the rest should be pretty straightforward. You're going to use this PV-nRT for every equation on this paper, and then R will always be 0.0821, and it needs to be liter atmospheres per moles Kelvin. So if you do have any questions, let me know. You can email me or ask me next time I see you. This will be due today, which is Tuesday, for the even periods and 8th period. And then it'll be due, or that's it. Today, Monday, everybody's was due today. So if you do have questions, let me know. Have a great day.